In this video, we will talk about how to find absolute extrema. So those are absolute mins and absolute maxes of multivariable functions. So I want to begin by recalling what absolute mins and absolute maxes are for one variable functions. So I want to begin by drawing a graph. So I'll draw my y-axis and my x-axis. And let's say that I'm looking at my function over some interval from some number a to some number b. And let's say that my function looks something like, so it starts at a point here, goes up for a bit, then goes down for a bit, goes down a little bit further, and then goes up, and then it ends here. So if I look at this picture, I can see that there is a local max at this point. It's sort of the top of a hill here. There's a local max there, and there's a local min at this bottom point. That is a local min. But we can also identify the absolute max and the absolute min. So the absolute max is going to occur at the point that has the highest output. And that happens here at this rightmost point of the interval. This is where the absolute max is. We have the highest output. In this case, the y value. The highest y value occurs at that point. What about the lowest point, or the lowest y value? Well, that's right here. So the absolute min just so happens to be at the same place as a local min. Well, that can happen. So now that we have this picture, reviewing local maxes, mins, and absolute maxes and mins, I just want to recall, just conceptually, in general, what each of these terms means. So a local min, conceptually, is a bottom of a valley. Bottom of a valley, kind of like I had here. We had this valley kind of scaling down to this bottommost point where that was the local min. That was the bottom of the valley. A local max is a top of a hill. So in our graph, we just had one of these hills, but it's possible to have multiple hills and have multiple local maxes and even multiple local mins if I had multiple valleys. An absolute min is the lowest point on the graph. And by lowest, I mean the lowest possible output, whereas the absolute max is the highest point. The highest point on the graph. So the point with the highest output. So one convention that we're going to use is when we talk about local mins and local maxes, the endpoints of our interval. So in this case, where A is and where the B is, the endpoints aren't considered local mins or maxes. So that's why the absolute max, for example, wasn't also considered a local max because it was an endpoint. This is just the convention that we are going to follow when classifying endpoints. We're not going to consider them as local mins or local maxes. Okay, so now let's talk about multivariable functions. Okay, so for multivariable functions, we have this second derivative test. But the second derivative test is for local extrema, for local mins and local maxes. But now the types of questions that we're going to be looking at will ask us for the max or the min, rather than the local max or the local min. So when a question asks simply for the max or simply for the min, this implies it wants the absolute max, or if it's asking for the min, the absolute min. Okay, so and to find that, we will actually just make an assumption. We will assume that the local extrema we get, so the local extrema we would be getting from the second derivative test, we're just going to assume that they are absolute extrema, that they're the absolute mins and absolute maxes. Okay, so I'm going to highlight this. So we're just going to be making this assumption. So in all the remaining examples that I'll work out in this section, it'll turn out that the local extreme points are absolute extreme points. So this assumption will be a good one. But in general, this assumption isn't always true. If in a more higher level math course, I might spend more time talking about how to verify this more carefully. But in our class, I want to focus more on doing computations and finding mins and maxes. So I'm just going to make this assumption. So in the next video, we will talk about how to maximize a multivariable profit function.